The wing design has to meet certain design criteria. Essentially, the spar must fit inside the wing profile, take the load specified, and be made as light as possible. We begin the design process with the conceptual stage. Here we built mock-up spars to compare A-fold, B-fold, 45-degree cut, and crushing. We decided on a main load carrying spar manufactured with the crushing method for its simplicity. Following the conceptual design is the preliminary design stage. We found the maximum cross-section to be 45 by 45 mm and ran stress calculations through Excel. This allowed us to reduce the cross-sections for other test spars and further validate Excel. Next is the detailed design stage. The thickness of the foam was a set value at 5 mm thick. We used Excel to calculate a minimum spar cross-section that would survive the loading. We found this to be 35 by 40 mm. We also found that we used 20 grams of hot glue on the first spars, doubling the effective weight. We were able to reduce this to 2 grams. Finally, we move on to acceptance and evaluation. After plotting all the data from the 3 different spars, we found Excel and SolidWorks predicted worse performance as all the spars performed better. The spars exceeded all of the criteria for the final spar. This meant that we could now focus on reducing weight. Taking all of our data into account, we started the next iteration cycle of the design process. There are 2 main ways to reduce weight: cutting holes and tapering. We decided on cutting holes as this meant every rib could be built the same. The manufacturing of the spars was also more straightforward and paper could wrap around the spar more easily. We ran some SolidWorks simulations and built it to validate SolidWorks. Naturally, the spar had greater displacement than before, although it was still within limits so we could lose some more mass. We made a new SolidWorks model, completed assembly of the wing and ran simulations. Next was to build and test this final iteration spar. The spar performed well, passing the torsion and failing at exactly 1 kg. However, at load factor 1, its displacement was 16 mm, 1 mm outside the range. Cutting holes like this got us a 15.5% reduction in mass. However, variations in the density of the foam caused the spar to be heavier than anticipated.